Wait, why would it be negative?
All right, so let me go over these two problems. I would say these two problems will be a pretty good indicator of what you expect to see tomorrow. Okay, so again, tomorrow there are 3 questions. You need to sketch graphs for those 3 questions. You need to write equations for those 3 questions. And for one of those 3 questions, it's more like the bottom parts that you have the part B, part C, part D, where you have to use a calculator to find out the remaining values. Okay, so nothing else. Okay, just that. Okay. Now, so yes, yeah, hope you're yeah. So this now I would say this one it's a little bit challenging because the diagram may confuse you a little bit, because you tend to think about y as the vertical distance, but then we are now saying, oh yeah, this horizontal distance thing is y. But now, how do you make sense out of this graph? It's that time keeps going, but his position, it's going to fluctuate back and forth, back and forth. So that's why you would put the y value in the y is your vertical axis, and your time it's your horizontal axis. And then it sets at time equals to 2. It's on the one end of the swing, which is -23. So I would like to apologize, even though I didn't make this worksheet, but it's kind of hard to draw. So you have a -23 right here at time equals to 2. Okay. And then it sets what? It sets at time equals to 5. He's at y equals to 17. So you just go further down. So arbitrarily, maybe right here, that's 5. And then he is at 17. All right, so that's the graph. And you can kind of sketch the graph right here. And just like what we did for the past few days, we're going to figure out all the amplitudes, midline, and period. So let's take a look at the period first. What's a period in this case? So it is 6 because it takes 3 seconds from it takes 3 seconds from the lowest point to the highest point. That's half a cycle. So in order to go back to the lowest point, it would take another 3 seconds. So the period is 6, and right there we know the b value is pi over 3. All right. Where's the midline? Well, the midline, it's going to be the midpoint between 17 and -23. So whichever way you use, you can add them up and divide by 2, or you can try to find out the distance. You can find out the distance and then find out the total distance. You can find the amplitude and then figure out the midline, one way or the other. But you will find out that, well, the way I'm going to use is that I'm going to add these 2 numbers together, which would give me -6, and divide by 2, that gives me -3. Okay, so I know that my midline, it's going to be y equals to -3. Also meaning that my d value is -3, shifted down 3 units. And because I know the midline, then I know my amplitude. So midline and amplitude, they go hand in hand together. So if I know my -3, it's my midline, then the amplitude is 20. That gives me a value of 20. Now, this is the part that it's that you have 2 options. Okay, you have 2 options of deciding what the c value is and how you write the function. Now, it depends on whether you want to use a cosine function or a negative cosine function. So let me consider the cosine function. Cosine function starts at the top. So the top, it's right here. The peak is right here. So we'll say, all right, so if I'm going to use the just regular cosine function, I'm going to say it is 20 cosine, and then b value is pi over 3, and then t minus 5, and then minus 3. Okay, if you want to use cosine function because you can see the peak right here, then you just describe the shift right there. It's 5 units to the right. Now there's another equally acceptable answer, which is like, oh, I can see that it starts at the bottom. What starts at the bottom? Negative cosine. Anyone chose to write negative cosine? Okay, so if you feel like, oh, I can see the lowest point, and you want to say, oh, I know the negative cosine will start from the lowest point, that's fine too. If you want to use negative cosine, then you would have negative 20 cosine pi over 3, and then t minus 2. Okay, so either way would be accepted. So that's why I'm not going to write down C right here, because it really depends on what you use for your cosine. Because when we presented you the data, we presented you the lowest point first, so you have the option. Unlike yesterday we presented you the highest point, so it's more convenient to think about just positive cosine function. So you would put this equation into your calculator, and then you would type in, you would trace, okay? You would use the trace function, okay? Again, you would go to menu, trace, and then graph trace. You type in 2.8, and see if you get the same answer that I did. If you have 2.8 seconds, I got y equals to negative 16.383. Yes? Yes? For 15, I got y equals to negative 13, flat. And then for t equals to 6.3, I've got y equals to 1.158. So if you get the first one, right, chances are you would get the second, you get the remaining two correctly, because that means you type the equation correctly, you know how to use the trace function, so that should be quite reassuring. Yes? Well, at the very top, it says give your answer correct to 3 decimal places. So that's why I put down 3 decimal places. Well, like for this one, it's a flat negative 13 because it is flat negative 13. So that's why I would just write it, because there's no rounding required. For other ones, then you may need to round. You may. Where was Tarzan when Jane started the stopwatch? That means time is equal to 0. So when time is equal to 0, okay, so you do trace again. You would do trace again, and then you will have y equals to 7. Okay, you will have y equal to 7. And then it says find the least position value of t. That means shortest time. That's also positive. Where Tarzan, it's directly over the riverbank, where y it's equal to 0. Okay, so if you actually plot the graph, I think I didn't make a decent enough graph. You will find out that it actually cuts the x-axis or the horizontal axis pretty close to the origin. So you would get the time it's equal to 0.356. Okay, 0.356. So now for this one, I do want to verify with my graph. So 20 cosine of parentheses pi over 3 close parentheses open parentheses x minus 5 close parentheses close parentheses again minus 3. Now I do want to emphasize one thing, that is I've seen quite a few students not paying close enough attention on the parentheses. meaning that they might have, when they close the parentheses for x minus 5, they thought that was it. And then they type in the -3 without closing it, and then the calculator closed the parentheses for them at the very end of it. And that was very, very problematic. So after you type your equation, make sure that you check with your equation on the screen to see if it matches exactly as you wrote on the paper. Okay. And that's the point right here in between 0 and 1. So I would use the analyze graph. I would use the 0. And I'm going to highlight this part right here. And that's how I got my number, 0.356. Okay, when y is equal to 0, my t it's 0.356. Right, I think the challenging part of this question, this particular part E, this question, is that when you drew your graph, the point that cuts the x-axis or horizontal axis is between 2 and 5. But if you look at the whole graph, there is an x-intercept prior to 2 comma negative 23. So that's something you have to look into the graph and say, all right, I've got this. Yes. Always in radians. Always in radians. When you make the graph, you always do it in radians. All right, so for the second question on the back page. Now this one is slightly different because we don't have time for this case. It's just two different distances. We have a vertical distance and a horizontal distance. Okay, so we are not going back and forth. We just have a portion of the graph. So consider that this is the sinusoidal function. That's the cosine function. And the domain, it's only going from 0 to 50. That's it. That's a domain. All right, now we are starting at the highest point and the lowest point. So the height of the height from between the highest point and lowest point, it's separated by 30 meters. I saw some students too. I messed up initially. I thought that the highest point is. I thought the highest point was 30. I thought. And then I drew I labeled my graph. This is -3. I did my midline. I was like, wait, hold on. That is somewhat strange. Let me read the information again. And I discovered that the height is not, the actual height is not 30. It's 30 meters away above the lowest point. So the highest point is 27. And that actually gives you the amplitude of 15. And if you know the 15, then you would know the midline, which is 12. Okay, so that's a graph. So that's 50 right here. Okay, and then what do we do? We can find out the period. The period is, in this case, 100, because from the highest to the lowest, it takes 50. So to complete one cycle, it takes 100, and that gives us the B value of pi over 50. A, it's equal to 15, and there's no shift to the left or right. That's nice. We have the midline, which is y equals to 12. That means D is equal to 12. So we can write down our equation, which is y, it's equal to 15 cosine of pi over 50, and then x, well, just x, well, I don't need a parenthesis. I don't need parentheses actually. All right, and then plus 12. Okay. So, any question regarding to this graph, the sketch, and this equation? A, B, C, D values. Are we good? Okay. So, at 4 meters. So let me write it this way. At 4 meters, when x is equal to 4, what's the y value? Okay. Now, when it says how long is the vertical timber? How long is the vertical timber at the high? Wait, hold on. How long is the vertical timber? Yeah, at the high point. So that means at x equals to 4. Well, what is the height over here? What's the y value? And we say the y value, if you plug into a calculator, you should get 26.529. Okay, you should get the 26.529. Okay, at 4 meters. And then at 32 meters, you should get 5.613. So the vertical timber, it's this high. Okay. So basically just describing the y value, just the height. And then we say what happened if how long is the horizontal timber when that is 35 meters above the ground. So that means we are going to set y equals to 25. So when y is equal to 25, x is equal to 8.313 meters. Okay, so so you will find the intersection. Okay, so let me go ahead and plot this one out for you. So let me get a new graph. So 15 cosine of pi over 50 times x, and then plus 12. And I need to adjust my graph. Okay. So in order to find out the length of the horizontal timber, we have to set another equation. Y is equal to 25. So what we are trying to measure is the length right here. That's essentially the x value because x is the distance away from the y-axis. So if we can find out this point, we will be very happy. So we'll go to analyze graph, and then we find out the intersection. And then we say, all right, what's the intersection right there? The x value is 8.31. Let me change the display to float 5. I can see a few more digits. So 8.313 is the x value. That's the length of the horizontal timber. Okay. And then we say, what about if it's 5 meters above the ground? Well, if it's 5 meters above the ground, well, the horizontal timber is going to be pretty long because the x values are further down the axes. So so we do the same thing. We try to analyze graph to find out the intersection. So so we got 32.727. 32.727 as our length for the length for the what's it called, horizontal timber. Okay, so finding the intersection. So when y is equal to 5, x is equal to 32.727 meters. Now, one thing I do want to remind you is that when you look at your notes, when you're reviewing tonight to prepare for the quiz tomorrow, it's extremely important that you know how to operate the calculator. And my personal worry, okay, for students who may not get a straight A tomorrow is that, do you know what to think so that you know whether you are tracing the graph or you have to set a new equation so that you can find the intersection? Do you know when is which? Okay, what circumstances would you use the trace option? What circumstances would you need to do the graphing a new one and find the intersection? Yes. Okay. All right, so where does the track first go below the ground? So that means we want to find out the track that's gonna dip below the ground. Well, the horizontal axis is the ground. That means we want to find out where is the location that we see the x-intercept. So we find out the 0, and on your N-Spire calculator, you can find out the x-intercept very easily. Just go to Analyze Graph, choose 0, you highlight the region, and it pops right out in front of you. So 39.758. 39.758 meters would be the distance. Okay, so to conclude, I think we pretty much did the same thing for the past 3 days, including today. It's very simple. We just used what we learned last semester on making graphs for sine and cosine function, and in this case, we are using cosine function specifically. Nobody should write down sine function tomorrow. Nobody, right? Even though it's called sinusoidal function. Just make sure you know you are naturally curious about all these data info about amplitude, periods, midline, the shifting. When you get the right equation, make sure to type them properly, enter them properly, check the equation before you do any further operations, and that should be good.